Hello, my name is Irene Aldridge. Thank you so much for joining us at our first installment of Big Data Finance Online Edition. And we're very grateful to our sponsors, Suite LLC and Finametrics, as well as Able Markets and Finance Concepts for making this event happen. We welcome you to explore additional information on our website. It's bigdatafinance.org. And we look forward for you joining our upcoming conferences in New York City and elsewhere. So please stay tuned. Now, what is big data finance is about? A lot of big data is about obviously processing extreme amounts of data that we're surrounded by. And today, at this point, we're going to talk about social media. Social media is a huge amount of data. A lot of it is user-generated data. And the question is, what do we do with it, and how do we use it to our advantage, particularly in finance and investing? So please join me on this journey. And please, if you have a question, please email it to me at irene@ablemarkets.com. Here's my email address at the bottom of the page. And do not hesitate, and I will respond to you as well as to everybody else on the website as soon as possible. Thank you after this presentation. So let's start. Okay, so this is what we're going to talk about in this segment. We're going to talk about social media, where it's coming from, what its implications are, as well as technology, news, sentiment, natural language processing, government data, and of course the risks. The risk of social media, and then we're going to talk about the Internet of Things and the adoption of Internet of Things. Now, a lot of these things have been documented in the new book that I co-authored with Steve Crossu. The book is called Real-Time Risk. Here it's cover on the bottom of the page. And the full title is Real-Time Risk, What Investors Should Know About FinTech, High-Frequency Trading, and Flash Crashes. It was released by Wiley this year. You can order it on Amazon. And it's an overview of various risks that we now have in real time that we did not have before. Now, if I may draw your attention to this cartoon, I think the main risks associated with social media go precisely as described here. So you have one person sitting somewhere eating sushi, and you have a data scientist observing the behavior of this person and judging, drawing inferences about this person's future behavior. And part of it is investing behavior. Now, how can we observe this person, and who can observe this person eating sushi? The answer is pretty much anybody with access to information, such as phone information, for example. So your smartphones capture all sorts of records, your geolocation records, to the point they can establish whether you're at a restaurant. They can see whether you're Googling to see which sushi is better, salmon sushi or tuna sushi, and on the basis of which they can make a decision of what you're actually ordering, as well as they know who you're at the restaurant with, given your social media interactions, et cetera, et cetera. In other words, the world has changed dramatically to the point where everybody has a huge set of information that they actually volunteer in many cases to social media networks and definitely to your phone companies. And on the basis of this information, people may make decisions about your behavior in particular, as well as behavior of a segment of the population. And it's the risks of that are quite real. The risks of that information privacy alone, even though we're not going to get into that. But consider, for example, in New Zealand, there's a small town that volunteered 40 years ago to make public health records of every person. And it's something that they have been doing for the past 40 years. So you have 3 generations of people with medical records that don't contain first name and last name, but contain all other information, such as the year of birth and various medical information. And and this is public information. So somebody recently has taken this information and correlated it with the data on credit scores in the same town. So again, this person did not have the information identifying names of people, but they did have enough information to join the two data sets. So they had information on the date of birth, for example, of individuals. So what they've established is that people who have a bad heart condition are very likely to have poor credit score. In fact, the worse was the heart condition of a person, the worse was the credit score. Now, I'm not sure about whether they tested the causality and whether it's the bad credit score that causes a bad heart condition or bad heart condition that causes bad credit score. But the bottom line is that they were able to determine the credit score so reliably that if you went into the bank, if somebody went into the bank didn't need to even look up their credit score. They could just ask them about their heart condition and establish their credit worthiness. So issues like this are extremely important to understand and deal with in the big data setting, and this is what we're going to talk about today. So first of all, let's draw a distinction between social media and news. Traditional news is chosen by editors based on their subjective newsworthiness. Now, this newsworthiness is often press releases supplied by companies, or when I often talk to journalists, they tell me that over the years they developed a network of sources through which they source their information. And this is all fine, but the bottom line is the news editor's set of information can be somewhat limited by their worldview, of their personal preferences, their social interactions, etc. And a lot of news falls under the radar because it doesn't get the attention of news editors. Now, the internet today takes over, and everybody's broadcasting on the internet, and everybody becomes their own news editor. That's what really social media gives you the ability to do, is to create and edit your social, is your news. So even this ability is not just limited to people. We also have robots and other inanimate objects creating news feeds. And some of them are specifically programmed to do so, and some do so by kind of a secondary function. We have sponsored content also that tries to blend in with legitimate news, which is very difficult sometimes to disentangle. And we have blogs by reporters and the public, and they're updated continuously, and they're continuously changing. And of course, we have a ton of comments on each post and each article. And the result is that we have this massive data series, which, if used correctly, can be used to derive valuable information. So this information is, for example, we take Brexit. What could we have done with Brexit? So the problem with Brexit is, from the financial standpoint, we'll ignore, wave our hands around all the political implications. But from the immediate financial standpoint, if you were a portfolio manager and you bet that Britain is going to stay and not leave the European Union, then you would have experienced a severe shock in the British pound value. So the question is, could you do something by analyzing social media to actually figure out what is going to happen, the outcome? And the bottom line is, if you analyze the social media from the psychology 101, marketing 101 perspective, you would notice that most of the content surrounding the Brexit, whether it was pro and most of it was against Brexit, it was official media content, talked about Brexit. They did not talk about staying in the European Union. They talked about exiting the European Union and the pros and cons of exiting. And in marketing, there is a concept of reference, and that people are more likely to be leaning towards the most commonly named word, whether it's a brand or a concept or anything along those lines. So just by counting and estimating how many people were pro-Brexit and against Brexit, you could have an idea about where the majority of the public was going to lean. So ultimately, Brexit won and Leave won, but it was not a surprise so much for people who understand social media and track social media. Now, so and this is documented in several social media studies. But bottom line is, similar research shows that most publicity is good publicity. So whenever you mention a concept or an idea or a person, then this builds awareness, consideration, and ultimately purchase retention and advocacy of that particular idea or concept. And this is really what was behind Brexit. And marketing psychology is very important in finance, and it's growing in popularity. And social media allows us to delve deeper into the analysis of how it affects news, etc., affects the outcomes and social psyche. So perceptions are very important, and today we can reliably estimate how people are feeling based on their actions, because we can track not just the market dynamics, which are very important for finance, obviously, but also people's emotions, etc., is expressed in other forms, such as social media again. So this is, for example, is index generated by our company, Able Markets, and it's for Apple. So we track social media mentions of various companies across different websites. And what we find is for companies that are a majority of which stock is retail trading, such as Apple, our index is extremely predictive in their price movements, and it's usually a leading indicator of where the prices are going to go. And this is the case, mostly the case with Apple. It's also our social media we find is very predictive of volatility. These are, and again, these influences are much stronger for smaller stocks that are traded specifically by retail. So this is an example of our index, Able Markets social media quotient versus intraday range volatility for VMware. So again, our index predicts, is a leading indicator for volatility for stocks that are traded by retail. Other research, other things we can do. So let's say social media impacts, but you're not sure whether it's a reliable source or not so reliable source. You can develop a computer score where you weigh the source by credibility. So, and you can assess social media users, web sources, blog publishers, even specific formal media outlets. And this is there is a obviously famous case when AP Associated Press account, Twitter account was hacked, and somebody posted fake news, and the market reacted instantly, but corrected itself after a while. So bottom line is, by establishing credibility score, you can assess or determine or correlate news sources against each other and figure out what news is reliable and what not necessarily. Okay. Similar with Twitter, you have a lot of computer-generated content, which basically creates noise, and you need to establish what is a signal and which is noise, and correlating with several reliable sources among each other may help to do that. Now, of course, social media is widely enabled by technology, and iPhones specifically and other smartphones have been major drivers behind social media, because now we can produce content on the fly. We can do it on the subway or on the beach. And there's a new group source of sort of process information vendors that provide sentiment analysis to not only just count how many times something was mentioned, but try to understand how people feel, or the authors, or what kind of sentiment does the content contain. So there are two ways to analyze sentiment. One is the brute force, and the other one we'll talk about in a bit. So the brute force analysis is used by companies like Grab and Pack and Sense News. And what they do is essentially take in the article and then classify the words based on their positive or negative estimate, kind of score. And the score, positive and negative score, is determined in advance. It's stored in the dictionary. And for example, positive words include words like happy, increase, expansion, and profit. And negative words are losses, declining, recession, and other negative words. And total sentiment is calculated as a score. So you calculate number of positive words, you calculate number of negative words, and then you do a ratio on the bottom, in the denominator. You have the total sum of positive and negative words, and in the numerator you may have a number of positive words. That gives you a score from 0 to 100 of how positive an article could be. This is a pretty straightforward assessment. Again, it's a brute force sentiment analytics that is very, very common. The result of it are subjective. Again, in many cases, sentiment that it does not really add additional information outside. It does not impact people as much as the actual number of mentions of articles of something. But it's out there. So we can also do another assessment. If, for example, you read the news and then there are a lot of people commenting on the news, you can deduce an agreement score by considering how many people in the comments actually agreed with the original article. And comments often turn out to be more interesting and insightful than the article itself. You also, but they're harder to process because you have abbreviations such as LOL, laugh out loud. You have emoticons, cute faces, and it's also difficult to process sarcasm, etc. That's something that's not necessarily readily accessible to computers. Still, we do have technology to process human speech and determine what people are really thinking. And this technology is known as natural language processing. So how does natural language processing work? Well, we don't separate positive words from negative words, except we discriminate between phrases. And how do we determine these phrases? Well, here's a natural language processing step-by-step. So first step is to remove all punctuations, hashtags, and words like the. Second, we convert all remaining characters to lowercase for consistency. So now we have terms, and these are technical items in natural language processing. Next, we clean up the words. So we basically discard all the words that that are not present in Harvard for dictionary, you may discard more than you want to discard. For example, there are abbreviations such as bought and sold, and other technical terms that may not pass Harvard filter, but these are application-specific items. The next step, you perform what's called stemming. So in stemming, you separate the stems of the words from their prefixes. On the basis of the prefixes, you really determine the sentiment, whether the word is positive or negative, such as D, on, or pro. So D would be negative prefix, as would be on, and pro would be a positive one. but you may run into trouble with words like communications, which is can be both positive and negative or neutral. So next, after you have these terms and they've been destemmed, you perform latent semantic analysis, or stemmed rather, perform latent semantic analysis on the stems to figure out which words were the most commonly occurring. And the idea is that articles are self-supporting. So the author of a paragraph or an article, when making a point, uses many different related concepts to reinforce its main point. So you will have a lot of synonyms and other kind of related terms within the same piece of text that clustering technology will deliver to you. Finally, we perform classification, supervised or unsupervised. In supervised, you actually give a dictionary to the computer program and say, tell me what the output is relative to my dictionary. In unsupervised, the machine delivers you clusters of information based on its own analysis. Obviously, machines make mistakes. So there was a well-publicized case in 2008 where in the middle of the night in 2008, somebody looked up a long forgotten article in Orlando Sentinel that was from 6 years ago, and it dealt with United Airlines filing for bankruptcy. Now, Google picked up that there was an increased internet search activity on United Airlines and in Orlando Sentinel, and actually made it a trending article. And of course, it was in the middle of the night, so there was not much of other activity going on. So next, a reporter looks up the content and this trend index, forgets to look up the date of the article, and writes a story that United Airlines is about to go bankrupt. And once the market opens, the United Airlines stock plunges 76%. So it's really is a story of bad computer-human interaction, but the moral of the story is there are serious risks of machine interpretation, and humans have to be careful dealing with those. Now, what's coming soon on our horizon is new technology, of course, that tracks not just what you type, but how you type it, and determines your mood, etc. from this information. Now, in addition to social media generated by individuals, of course, there's social media now generated by governments. For example, New York City is one of the first cities to open a lot of its data. It's available publicly and used by many hedge funds to mine economic conditions. For example, if you have parking tickets, it means it perhaps denotes the increases in parking shortages, which in turn signifies more demand for parking spaces, more consumer demand, and probably higher consumer confidence levels. Similarly, New York City trash data is predictive of upcoming macroeconomic conditions. Now, with reliance on social media comes significant risks. Generally, the people who get access first to this information are the first to benefit from the information. And it's basically first come, first served. Now, next, there's the risk of updates. So government data, for example, is well known to be revised and updated over sometimes several times. Now, social media can be subject to internet outages, malicious hacks, and other activity. And even Internet of Things data can become corrupted. And Internet of Things data is something we're going to talk about next. So how do we manage the risks of all of this? And the answer really boils down to three key aspects. So we have to create redundancies, we have to increase data sampling pools, and we have to use averaging to get rid of outliers that may be results of hacks or other information that doesn't fit within everybody else's information frontier, if you will. So what does redundancy mean? Redundancy literally refers to keeping multiple copies of pretty much everything. So we're talking about data sources, databases, power, processors. And what does redundancy do? It helps us deal with temporary outages or some corruption issues, data corruption issues. So this is something what Amazon Web Services gives us, AWS service gives us when we purchase their cloud services. So a cloud, Amazon Cloud in particular, is really a collection of many servers that are interconnected, and they are what's called balanced load. So if one server fails, then other servers pick up the load of informational load, processing load of the server that failed. So the idea is that there's continuous uptime even when some computers are out of service, and the clients, which is data analysts, don't have to worry about this. Now, in reality, you may remember about a year ago, there was a Monday when Amazon Internet Web Services went completely black in the United States for the entire day. And that affected pretty much half of the US businesses. Even HSBC was completely down because they rely on Amazon Web Services for their infrastructure. So again, relying on the third-party provider for your needs, you're becoming dependent on that third-party provider. And again, redundancy in distributing your even third-party providers is useful when in risk mitigation. So next, risk mitigation is source diversification. So if you're exclusively relying on the New York City website, and say the situation arrives where the New York City mayor decides to terminate the website, New York City information, and that just puts closes your business. So the idea is to diversify your data sources so that even in the event when one data source disappears, you still have other data sources to pick up the load. Finally, data averaging. So let's say you have a website that's been hacked and it starts delivering information that doesn't correlate at all with what other data sources produces. If you have a significant data source diversification, you will average out that anomaly and still have a very kind of consolidated flow of information that you're processing, which is valuable to your business. Now we're going to talk about the Internet of Things. Now, as you know, some 30 years ago, the Internet barely existed as we know it, especially as we know it today. It barely existed at all. Now, today, there's increasingly Internet of Things that it speaks for itself. So many items that we commonly use transmit information to various sources around us, some of which we may or may not be aware of. So, for example, so there's pricing information on various factors, on various products, and it used to be a separate job description to collect and compare pricing information on various competitors. Now today it's all done by companies like ThinkNum that scrape the internet essentially and deliver kind of packaged data information. Also, you have every container is labeled with a device that uniquely identifies its source and destination and other information about, such as what does this container contains. Now, a lot of this data is transmitted using these RFIDs, radio frequency identification devices, which you've probably seen in your local pharmacy. But there are many more devices like this that are being deployed and used. Now, the advantage of these RFID devices is what they're called passive. Now, what it means by when we call them passive is that they do not contain an electric source, and therefore they're costless to run. And in principle, they can last for infinite amount of time as long as they're not broken. And also they don't emit any heat, so they're really undetectable until you activate them with a device of selected frequency, at which point they respond. Now, not surprisingly, these RFIDs were developed during the Second World War as a spying technology, where people would leave essentially encoded messages for each other at these selected frequencies that were only accessible at these selected frequencies. But they're very inexpensive to manufacture, they're widely available, and they're being increasingly tracked, and the information on their location and use and other associations, such as whose credit card the device was purchased by, or the item with the device was purchased by, is being stored and potentially can be used to derive financial information. So they can be mapped to everything. They can be mapped to, RFIDs can be mapped to the product code, to spatial coordinates, and can be used for many different things. So Amazon uses RFIDs to optimize warehouses, farmers track their livestock, and fleets track their containers. But all of this can be translated into profit if used properly. But bottom line is we barely scratch the surface with these Internet of Things devices, and we have a revolution of these devices coming to us, and with the explosion of data, and we really have to, we cannot really afford to avoid this data anymore, but we need to know how to use it and how to process it. And this is where big data is extremely important. So the Internet of Things, again, is exploding. It's continuously growing across various segments, and it's expected to be growing even faster, especially with the phones and businesses, et cetera, et cetera. Now, we're running out of time right now. If you do have any questions, please send me an email at irene@ablemarkets.com, and we will respond to and online for everyone to see, and to you personally. And thank you so much for tuning in. And I hope to see you again at our conference tomorrow, as well as our future Big Data Finance conferences. You can access them at bigdatafinanceconference.com or bigdatafinance.org. Thank you so much, and have a great day.